Welcome again. Welcome again to our virtual pre-lab or lecture. Today we are going to look at the experiment on scientific method, how science is done. I know if you're taking the lecture right now, you have covered the concept of scientific method. It is a way of doing science across all discipline, biology, physics, chemistry, and any other science field. There's a way of answering the questions around any concept which there is a laid out procedure. There is a handout I'm just going to go through in details. First, I'm just going to go through in details what we're going to do and what you need to do in every activity in the lab, all right? Activity in the lab, which I hope you have read the background. I recommend that you always read the procedure before coming. However, if you did not, please go back again and download if you need download and read the background before you start the experiment. I'm going to share my screen, and what you see on my right or on the right side of the screen is the lab procedure, the manual. I do have this document online in case you're wondering where it is. It is on posted in the modules, all right? Under the modules, you will go to today's lab and download the document. Just in case you're wondering where the document is, this is today's lab, and there is, this is the PDF form. The handout, or rather the data sheet, is posted in the assignment folder here. If you didn't attend last week, this is where I post the handout, and right now I do have the handout for today's experiment, the scientific method. I'll walk you through this document so that you know how to complete the data sheet, all right? How to complete the data sheet. There will be a quiz on today's experiment. It's going to be based on the background on scientific method. So let's see the scientific method, what is all about in scientific method. When we say scientific method, what are we talking about? In particular, what are we supposed to do as far as our experiment is concerned? For today's lab, I want to walk you through the procedure, the background, all right. Explain some of the terms so that when you look at in the quiz, you'll be able to distinguish or differentiate different terms associated with this experiment. So let's see. What we're gonna do is look at the questions and be able to state the scientific method in relation to the experiment, that is the looking or investigating the rate of dissolution of anti-acid tablet, all right? Faster, flop, fizz. We will look at the rate at which the anti-acid dissolve, all right? Anti-acid dissolve in H2O, given amount of H2O at different temperatures. So at the outset, how do we define, all right? How do we define the scientific method. When we say scientific method, what is it all about? In scientific method, I'll just look at the broad definition of scientific method. This is simply the systematic investigation. Scientific method. I'm looking for my stylus to write the general definition of scientific method. This is simply systematic, all right, systematic investigation, all right, investigation of nature, all right, nature that requires proposing, all right, proposing an explanation of results of an experiment. This is simply the general definition of scientific method: systematic investigation of what? Of nature that requires proposing an explanation of results of an experiment. So if you end up with the results, you got to explain to that. And it start with proposing an hypothesis. These are the terms you need to understand, define in your own word when we say hypothesis, all right? This is an educated case. Sometimes we define this simply as a statement, all right? Statement that has not been proven right or wrong, all right? It's just a statement. It's an educated case. Some people define this as an educated case. So by the end of this exercise, or through this, you should be able to come up with an hypothesis and understand independent and dependent variables, control variables. These are the terms you'll see in the quiz, and you need to distinguish the difference between all these variables so that you apply in designing an experiment. You'll analyze the data. You will use a graph, all right, to analyze your data. In the last experiment, you generated a graph. We're gonna be using the graph again in this lab to analyze our data. Recall the graph convey a message. It tells a story. So the graph you'll generate, you'll be able to draw some conclusion regarding your data. It takes about 90 minutes, at most 90 minutes, if you understand the background. I hope by now everyone has his or a lab kit, and in the lab kit, you will see the required materials, all right? You will need, some of them you may need to use something you already have in your kitchen, all right? You will need, apart from what we have in the, let me just fast forward to what we need. This is what you need. It came with, your lab kit came with 6 plastic cups. I do have it, you may not see it, it's transparent. You need 6. There is a 250 ml beaker. This is a thermometer. You're gonna need this to what? To measure the temperature of water. There will be 3 temperatures. You'll collect the data. If you don't have ice, I know, at some point I used to live in an apartment. I didn't have my refrigerator didn't have an ice maker. So if you don't have ice, I'll recommend that do not start the experiment until you have ice, or you can do the fast too, and then once you have the ice, you can collect the data. So you will need this. Hannah, let me just answer the question here. Look at over the lab instruction. It says that we have to cut the tablet half. Are we only dropping half a tablet each experiment, or both halves of the tablets? It is a half. You drop a half, okay, so that you have enough data. If I look at the rate, they want you to split it into 2, and thinking about that, if you have a whole tablet, it might take longer, twice as my time if you had half, which is the same thing. So use a half, and I use a half of the tablet. Yes, you're gonna need that. So for those of you who didn't or who have not read the background, you will need ice bath. You will need maybe microwave or electrical to boil water to around 60 or 70. All right, Chelsea. You're gonna need half. I'm just gonna demonstrate how you're gonna cut that into 2. It might not be easy the first time. So this is the Alka-Seltzer. If you use 1/2, or if you use a lot, a whole tablet, it might take a long time to dissolve. So having it half will be half the time. So this is what I was saying, that it doesn't come with your lab kit, medium-sized ball or glass to make an ice bath. So you're gonna make an ice bath. So if you don't have an ice, don't worry, you can just do the 2, that is water at room temperature, and you have to measure, just get the water, let it sit down for a couple of minutes, and take that as room temperature water. And you're gonna have ice bath. If you don't have ice, please, you can revisit this later on. Remember, the lab is due next Sunday, so I wouldn't really worry much that, let me wait until weekend, or somebody give me a ride to the convenience so to get the ice. You can do the 2 fast, and then you can do the ice bath later on. Hot tap water, yes, you can need that, and stopwatch, you can use your cell phone, all right, or kitchen timer for that. So these are the things you do not have in the lab kit, all right? Just to point out, so that when you get started, you don't just get stuck and say, oh, I didn't know that I needed ice. I didn't know that I needed a stopwatch. I didn't know I needed, an ice bath. So you plan to get that. All right, what I want you to do is, this document is available online. You will read the background, understand the bold terms. You need to know, them. You should be able to divine. Remember, all right, remember to download. Here is figure 1. Here is the summary of the roadmap in scientific method, that you make observation, you ask questions, develop an hypothesis, and remember what I define hypothesis is. All right. The other might have a different definition as the one I do have it here, but you feel free. This is how hypothesis is. All right. To test an hypothesis, that is a statement which has not been proven wrong or right. So that once you have your statement, You will now design an experiment so that, you know, you test the hypothesis, all right? Once you test the hypothesis, you either reject the hypothesis based on, you know, the results. It's not always true that the hypothesis will be proven right. Sometimes it can fail, and you may want to remodify your experimental design and analyze, synthesize. And some of these leads to what we call scientific theory, all right, or principle, all right, or principle, or even a law, scientific law. Those are the terms you will see in the lecture. Law, scientific law, all right. Scientific law is, scientific law state a measurable relationship between two things. For example, law of mass conservation, all right? You measure the mass of reagents before a reaction and mass of the product after the reaction. Law of mass conservation. All those has to do with using scientific method to develop that law, okay? Whereas a theory explains the natural behavior. Maybe I should write here, so that here is what I just scientific law. This one states measurable what? Measurable relation what? Relationship. Yes, relationship. This is how you define the scientific law versus scientific theory. All right, theory. This one summarizes natural natural behavior. It explains natural behavior. Theory of causes. All right, causes expand, and there is a reason why we have that. So with this, there are terms here which you have to differentiate between the variables, independent and dependent variables. And there is control variable, 3 of them. When we say variables, you will need to understand the 3 terms, because when it comes to plotting the graph in this experiment, there is a variable which goes in y-axis, there is a variable which goes in x-axis, and throughout, it doesn't mean that anything can go anywhere on the graph, all right? It will boil down to understanding the difference between independent and dependent. Independent, of course, from the word independent, that means it does not depend on the other variable. When we say dependent variable, that means that variables depend on the other one, all right? So I can just illustrate an example to differentiate between these two. The independent variable here is a factor hypothesized to produce the effect under investigation. This can be measured and is often controlled by the investigator, Okay. Let me give you 2 scenarios here, and then we will paint a picture and see if we understand the difference between the two. Maybe here, let me say temperature here, temperature, and death rate of fish, all right? Let me give you this illustration here to see if we understand or we can capture the difference between independent and dependent variable. Here is a variable right here, and here is the another variable. We want to draw a graph. I had one student a couple of years ago. She went to Walmart and put a cold fish tank, came home and boiled the water. She was trying to sanitize the water, like make it clean, and she boiled the water, let it cool down, and put it in the fish tank, and then put the fish in there, and the fish died, and she could not understand until when she took my class and I explained the reason why. And the reason behind that is, you know, the oxygen, the dissolved oxygen in H2O evaporated when she boiled the water, and there was no oxygen in water, and the fish died. That was the explanation. The student was like, wow, I didn't know, all right? She didn't know that. Now, I think 2009 in the state of Minnesota, the temperatures went all the way above 100 degrees Fahrenheit, and there was a lot of fish died in a lake because of elevated temperatures. They ran low in oxygen, all right? Now, if the temperature is right here, if the temperature, say in degrees Celsius, and the death rate of fish are two functions, which one depend on which? Which one depend on which? If you look at these two, the death rate depends on the temperature, but not the temperature depends on the death rate, all right? You can see this one is independent, this one is dependent. If the temperature goes all the way to 200 degrees Fahrenheit, a lot of fish will die in the fish, because of lack of oxygen. So the temperature does not depend on the death rate of the fish in a pond, but the rate depends on the temperature of water. In this case, if you look at these two right here, independent variable is a factor hypothesized to produce the effect under the investigation. So if we want to know the rate at which the fish die, we can vary the temperature. How many fish dies when the temperature is 30, when the temperature is at 80, when the temperature is at 150 degrees Fahrenheit, and then we count it to produce. We call this independent, all right? Independent. And then this one depends. When you do that, when plotting a graph, all right? When plotting a graph, it matters where the dependent goes and where the independent goes. Dependent is a variable that is measurable, but varies depend on the independent. So if I have here, it will be temperature here. This is the independent, and then this is the dependent on this side, dead rate on the x-axis. This is x-axis, and this is y-axis. So throughout, maybe outside this lab, always the independent or independent variables goes in y-axis, dependent goes in x-axis. So it's easy to see that the effect, all right? The effect that other variables, they do not affect the way it goes. So on the graph, know where the independent goes with respect to what? Y and x-axis, so that when you plot that, you will look at the graph and draw some conclusion. Now, in this experiment, you will use scientific method to answer some of the question: how fast does anti-acid tablet dissolve in different temperatures? When we say different temperatures, there are three, all right? There are three different temperatures. Let me pull up the data sheet so that we compare, all right? I thought I had my, oh yes, right here. I wanted to show you the temperatures. When we say different temperatures, this C stands for the cold temperature. Cold is the ice bath. And how you're gonna prepare your ice bath is you'll take your bowl, all right, your kitchen bowl, and put ice and water in there, and then you will measure the water with no ice. Maybe you can see this from where you are. I'm just gonna put ice in here and put some water in here. This will be the ice tap. I will measure now just only the H2O with no ice in there. I don't want you to carry the experiment with ice in there. No, it's just ice cold water. Just put it ice cold water. You just pour or put ice. You can see ice. You pour the water. This will be your cold run. And then there is RT for room temperature. And then there is hot for hot water bath. It can be 60 degrees Celsius, or you can use hot water from your tap bath, all right? Or even the sink, if you have hot water, you can use that. So that is what is stand for in terms of two experiments with different temperatures, right here. So three. When say different, know that there are three what? There are three water baths. You have to do that. You will formulate hypotheses based on the experiment, all right? And repeat this to determine the reproducibility of the data. So they will be, you'll run a couple of times, all right? You'll run a couple of times. This is run one. So I'll have what? I'll have, if you have somebody to help you out, say in my room temperature, these are the 3 cups. Equal H2O, all right? Equal H2O in all 3 of them. You will drop now the split, all right? You will split a tablet into 2. Follow the direction on how to split it equally. And then I'll drop at the same time and start the stopwatch and record the time it takes, all right? Time it takes to read the observation. You can do one at a time. If you are by yourself, I recommend you do this by itself. How long does it take? Room temperature, write the observation. It might be the same, that's fine. The temperature right here, you have to measure the temperature of the H2O before you do that. If you look at 1, 2, this means run 2, you'll do it twice for each, actually 3 times. So if I was to do the cold, I'll do 3 times, room temperature 3 times, and hot water bath 3 times. You have to do the average for all of them. You have to do the temperature or the average for all of them. Any question on so far? Let me see if someone has asked question. Y-axis. Question here, maybe I missed that. Olivia, quick question. Will the independent variable be, independent is Y-axis. Deborah, thank you. Yes, independent will be. Somebody answered that. That is correct, Deborah. That is correct. Thank you. Hope that clarify or answer your question, Olivia. It just means that it was hidden down here. All right. Any question on completing the fast or question 1? That is the data sheet. I want to be clear on how to collect the data. I know, you know, collecting the data is not a big deal. Any question? So this question is tied to a question on what goes on Y-axis, what goes on X-axis. Independent goes on y-axis. You can control that, something you can control goes on y-axis. Let's see, question 2 on the data sheet. You will use the software, that is the Excel we learned in the previous experiment, to generate a graph. All right, please see introduction to graphing guideline. At this point, you know what will go on y-axis, what will go on x-axis. Read the background to understand in this experiment what will be your what? Independent variable. What will be your dependent variable? Of course, based on what you have up here, you list down here what are the 2 variables using the graph. That means you have to draw to scale. If your water path is, all right, you have to draw to scale. Don't just draw it anyhow. Let me just explain that before I go to 3. Using a graphical software, please draw your graph to scale. If say room temperature is 0, all right, if room temperature is 0, all right, if room temperature is 0, time, if it run all the way to whatever you have to draw to scale. If it is going to 10, it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 all the way, it should be drawn to scale. Likewise, if the 0 to 100, it should be even. You cannot say 0 and then you go to say 1 and then you go to 2 and then you go to 50 like that. It is not drawn to scale. Make sure that it is drawn to scale. Make sure you label the y-axis, label the x-axis, and then you label or give the title to your graph. Remember, those are the 3 things. And you will also have to generate a, the data points based on that. Any question on 2? Just want to be clear on what you need to do on question 2 on the data sheet. Any question? Any question on 2? No question. So assuming that we are done with activity 1, room temperature, all those you'll have to use. And please use equal amount of H2O throughout. Otherwise, the experiment will not, it will be skewed, all right? So this is what you'll have in there. Now, you will list 5 questions based on what you will have. You list 5 questions about the rate at which you cannot list this unless you have looked at the first activity 1, all right? Once you see the observation, you will be able to ask yourself questions, all right? For example, in the analogy of the death rate versus death rate of the fish versus the temperature, will the amount of fish which will die double if I double the temperature? That's a question, all right? That's the question. Will the rate decrease if I decrease the temperature? That's another question. Different question based on the observation you see in activity 1. You will list different questions. Upon looking at the questions and the activity 1 observation, upon looking at the observation in activity 1 and the 5 question, you will now develop an hypothesis here, which you will test. Hypothesis, all right. If the rate of dissolution of antacid, if the rate at which it is dissolving is a function of temperature, or you can formulate your own hypothesis, identify the independent variable. You can do that based on activity 1, based on activity 1. Now the variables there, you can just come up with that. It's easy. Which variable is independent? Will it go on y-axis? You know, you will answer this y. You cannot just off or at the top of your head answer this y part. Y part, you need to read the background first on the to understand why do we put independent variable on y-axis? Why do we put, you know, dependent variable on y-axis? This explanation of why y is on the background procedure, which I don't want to. You can go back and what? And read on that to answer the question on why. What I wanted to point out is predicting how many seconds will it take to dissolve antacid tablet in 200 ml of water in the following temperatures using the exponential trend line. This one, we in the previous carving analysis experiment, you added a trend line, right? Everybody knows how to add a trend line. Y equals to mx plus p, where m is the slope of the line. All right. This is sorry about that. Let me just. This is what I'm talking about here. That I know, you know, this is trend line, right? Trend line equation, or just line of equation, which is m x plus b, where this is y into what? Y intercept. This is not what you will be using here. This is not, this is exponential. Look at what I'm highlighting, because if you miss this, you will give me this graph and it will be wrong. There's a difference between exponential trend line and just the trend line or equation of a straight line. In question 6, you will use exponential trend line to answer the question in predicting the what? How many seconds will it take? You're not gonna use equation of a straight line, but you'll use you know, the exponential what? Exponential trend line at 25. There is a way. You will just have to plug in 35, plug in 60, plug in what? The 80 degrees, 80 degrees based on exponential. Don't use this equation of a straight line. This is what you will use. I may want to send a YouTube on how to generate a trend line. It's pretty straightforward. Instead of having a straight line, you know, a straight line, you'll have something similar to this, like the line will just follow or go through your graph. It's not going straight, and you should have something similar to this. This is just an explanation. Yours might be like this. Yours might be like this, and the equation will be y equals to some value, maybe 5.28 exponential. You know this x, and then we put 0.25, and then here is the value for x. This is now the what? The different temperatures given on question. Let me just minimize this. I didn't want to. This is what I am talking about right here. So yours might be like this. So once you generate an exponential trend line, we call this right here, we call this exponential what? Trend line. It is not just a trend line. There is an E at the end. I will send a YouTube on how to generate, or instruction on how to generate a trend line, exponential trend line. And the X right here will be the different temperatures given in question, 6. Let's see question 6. If you look at this, it could be, now the X could be 35, it could be 60, it could be 80 given there. So if I have in your calculator, all right, y equals to 5.28. I'm just using my example here that if it is 35, if I want to predict, all right, how many seconds will it take? All right, to predict how many seconds will it take for antacid to dissolve at 35 degrees, predicting how many seconds will it take to dissolve at 35 degrees Celsius. From the exponential trend line, you will plug in the temperature given here where you have X, right here. If X is 35, you're gonna put X right there, 35. If it is 60, you're gonna put 60 right there. This is a function in your calculator. This E is on your calculator. And this is a constant which will be generated by what? It will be generated by computer once you generate the exponential trend line. I don't want you to generate trend line and just get a straight line equation and say, all right, I remember from experiment 1 how to generate a here is exponential. The keyword here is exponential trend line, and I expect you to have a graph similar to this before you plug in the given temperatures. That is the 35, that is 80. That is what you will do in activity 1. Any question on question 6? Just want to be clear on how to predict. Prediction has to do with this exponential trend line. I will post a YouTube, as I said, or you can ask your friend Google, how do I generate, exponential trend line from the data you will collect. All right, let's move on to activity 2. You list 5 questions about the rate at which alkyl cells will dissolve and the acid. All right, if the temperature was held constant and one of the variable was changed, there will be so many questions you can come up with. You will be guided for in activity 2. You will be guided by the observation. Once you are done with activity 1, at different temperatures, you will see how long does it take. Remember, predicting at 35, at 60, at 80, and then at that point, you can develop or you can come up with at least 5 questions if one variable is. And then you'll develop a new hypothesis and list the variable there. Okay, this is just for repeating the same thing. Once you come up with your hypothesis, you will test it the way you ran experiment number 1. Once you come up with your hypothesis, you will run the way we ran before. That is, you don't see it here. This is cold water. This is room temperature. This is hot water bath. This activity 2 or table 2 is based on your new hypothesis. How long does it take? You're going to record the time here and make the observation. Now you'll have to think critically what could have been done. This is a question. The follow-up question on activity 2 here is based on, all right, the follow-up question here is based on the overall results. That what do you think could have been done to improve the precision? Precision is how close a series of data to one another. For example, I can look at what? the room temperature alone, what could have been done to improve the closeness so that you get the same time? All the time you get the same value. That means if it is taking 20 seconds, what could you have done to get the same results all the time, to tell the truth over and over? You can come up with, you know, a suggestion on that. It's just a critical thinking question, which I think upon completing the exercise, it will be much easier. With that, that summarizes what you will need to do for this lab, investigating the scientific method. The handout is on in the modules. Please, if you don't know, if you are wondering where this document is, go in the modules and submit the assignment file, assignment folder on Canvas. All right, this is due on Sunday. The quiz will be due on Sunday. I don't want to, you know, put pressure on you. Too much is going on right now with what's going on. Be safe if you are making a trip to get the ice. All right, and we should be fine. All right. Other than that, is there any question? If there is no question, the class is dismissed. I will see you on Monday. Please be reading the background before you come, so that in case there is something you don't understand, you'll say, oh, I was reading this and I don't know. If you see anything, just send me an email. Sometimes I may be available and I can request that, are you in a position to come on Zoom and explain to you 1 or 2, 3, or I can send you an email if you say I'm at work and I cannot come on Zoom, or, you know, for whatever reason, I'll try to accommodate you to the best of my ability. Other than that, have a good morning. I'll see you again. Let me stop sharing my screen, and be safe. See you next week.